Hello and welcome to this lesson where we're going to be covering understanding quantitative comparison questions. Now remember, as I mentioned before, quantitative comparison questions are very unique only to the GRE exam. So if you're not familiar with quantitative comparison questions, this video is imperative for you to watch. So the first thing we're going to do is I'm going to go ahead and tell you some strategies on how to approach quantitative comparison questions, what quantitative comparison questions look like, and what are some strategies that you can use to perform well on these types of questions. So the first thing I want to do is just to give you a brief example, a quick example of what a quantitative comparison question looks like. So over here you have some directions. It reads, use any provided centered information to help you compare quantity A and quantity B. Select the answer that describes the relationship between the two quantities. Now notice in this case, we do not have any centered information. Just because you have a quantitative comparison question does not mean that they will provide you with centered information. Sometimes they do, sometimes they don't. If they do, you must go ahead and use that to your advantage because that's going to help you figure out the values of quantity A and quantity B. So I'm not even going to read this question because right now the main thing is what can you do to prepare for these types of questions? And the first thing you need to do is this over here. Memorize these answer choices. It's not difficult. This should take you less than 1 minute to memorize. It's very simple, but you should memorize it because this answer choice order is always the same in all types of quantitative comparison questions, where answer choice A is always that quantity A is greater. What does that mean? Well, that means that the value of quantity A is always greater than the value of quantity B. Notice I use the word always, and we'll talk more about that later on. Answer choice B states quantity B is greater, meaning that quantity B over here, and you don't have to read this, but whatever the case is, quantity B here is always greater than quantity A. And you would select B as your answer choice. And now moving on to answer choice C, the two quantities are equal. Obviously, that means that the quantity A is equal to quantity B. And finally, answer choice D always reads that the relationship cannot be determined from the information given. So here's a scenario where quantity A sometimes, so in some cases you have that quantity A is greater than quantity B. Sometimes you have that quantity B is greater than quantity A. And sometimes you simply can't figure out one of the quantities because there's not simply enough information provided. And therefore, you cannot determine the relationship between them. So these answer choices, this is a first step for you on succeeding on this quantitative comparison type questions. You should memorize these answer choices. You should automatically know what answer choice A, B, C, and D is because in your test day, time is crucial, right? You don't want to waste even 5 or 10 seconds because you may really need those 10 seconds to answer your last question on the GRE math section. So that is the first thing. Okay, so let's move on to the next slide. Okay, here are some very important notes over here. Quantitative comparison questions usually take less time than problem-solving questions. That should be a good thing. Some students love quantitative comparison questions. Some students prefer problem-solving type questions. I personally do really like quantitative comparison questions. I do think once you practice them enough that they can usually be done within 60 seconds, and it shouldn't really take you more than 2 minutes ever, even if it's a hard question. So moving on to the second bullet point, there are roughly 15 total quantitative comparison questions, right? Sometimes it's 15, sometimes it's 16. Basically, it's somewhere around that range. So 15 total quantitative comparison questions, which accounts for 38% of all math questions. What does that mean? It means that it's imperative that you understand these questions. Why? Because 38% is more than 1/3 of your math score. If you're just going in to take the GRE exam and you don't know quantitative comparison questions and how to approach them, well, you are putting yourself at great risk because these questions account for more than 1/3 of your grade. So this is very important. And lastly, the ETS, the official test creators of the GRE exam, is not interested whether or not you can perform lengthy and tedious calculations. What do I mean by that? Well, if a question looks like it is cumbersome in calculation, so there's a lot of calculations going on, that means that there is more than often a shortcut or a logical jump, and I'll clarify what I mean by a logical jump later on in the video, that simplifies a question. So if you're working on a question and you're computing, adding here, subtracting there, dividing, and it's just crazy, 99% of the time you're doing something wrong. The GRE is not interested whether or not you know how to do a multi-step problem by doing, all these different arithmetics. Instead, they care more about your logic, right? Do you know how to use logic to simplify the question? And I'll show you a good example of that just later on. So here are some bullet points. Let's go ahead and actually move on to some example questions. In this video, I have 3 examples of quantitative comparison questions. Okay, the first one is a easy one. We're going to start off with a simple question. So this is actually the same question that I used just 2 slides ago. So I have here quantity A, the area of a circle with a perimeter of 4 pi, and you have to compare that to the area of a square with a perimeter of 4 pi. So this one is straightforward. You can just go ahead and do the calculations because it's given to you and it's not so complex. It doesn't require much time. So here, what do we have to understand? The area of a circle with a perimeter of 4 pi. Well, the perimeter of a circle is the same exact thing as circumference. So that's the first thing you have to understand, that the perimeter of a circle is the equivalent of the circumference of a circle. And the circumference of a circle is defined as 2 pi r, or pi times the diameter, either or. And now you're given that the perimeter is 4 pi, so I already know the value of c. C in this case is 4 pi, and I can set that equal to the formula 2 pi r. And why am I doing that? Well, and why did I not use pi times d, the diameter for the circumference? I could have done that as well, right? Well, I didn't do that because take a look at this. The quantity A states that the area of a circle. Eventually, I want to find out the area of the circle, and the area of the circle is pi r squared. Notice my variable is r, the radius, and therefore I shouldn't even waste my time with figuring out what the diameter is, right? Even if I figure out the diameter, then I have to take half of that number. Why go through the trouble when I can just set it up in one shot? So now I have this over here. 4 pi is equal to 2 pi r, and I'm going to solve for r, the radius, by dividing both sides by 2 pi. 2 pi's cancels out. I'm left with the radius is equal to 4 pi divided by 2 pi, and 4 pi divided by 2 pi is just 2. So the radius in this case is 2, and now I can plug that right back in to the area of my circle. So the area is equal to pi times the radius, which is 2, to the second power. 2 to the second power is 4 times pi. So the area of this circle is 4 pi. So the area is equal to 4 pi. I'm going to box my answer. And now I'm going to move on to quantity B. Quantity B over here states the area of a square with a perimeter of 4 pi. Notice we are dealing with a square. A square has some unique properties. All the lengths are the same, so are the angles. Now, if the perimeter of a square is 4 pi, so P is equal to 4 pi, what does that mean? In order to figure out just one side of the square, I have to divide that by 4, since all of my sides are equivalent. So I can divide that by 4, and what do I have? The perimeter is equal to 4 pi over 4. This 4 over 4 cancels out, and I'm just left with pi, meaning that each of my sides have a measurement of pi. And of course, you can verify your work very quickly because pi plus pi plus pi plus pi is 4 pi, which indeed is the perimeter. Okay, so my ultimate goal here is to find the area of the square, and the area of a square is equal to side squared, or rather length times width, but the appropriate formula for the area of a square is side squared. So here is my side value, which is pi, and I'm simply going to square that, and there you go. Here is my answer. I have pi squared as my area of the square, and I have 4 pi as the area of my circle. So now we can easily determine which value is greater. We know that the value of pi is roughly 3.14. Obviously, we don't even have to use a calculator here. And just by the way, FYI, do not reach for the calculator always. You have a calculator accessed on the online platform. Please do not reach for that calculator when you don't have to. You are wasting your time, and that's a completely separate video that we'll be talking about on when you should use a calculator. But very simply, 4 times 3.14 gives us 12 point something. I don't care what that something is, it's just 12 point something. And then pi squared is simply 3.14 times 3.14. 3 times 3 is 9, and it's going to be 9 point something, right? I believe it's 9.8, something like that. I don't care, because clearly 12 is greater than 9.8, meaning that quantity A is greater than quantity B, and therefore the answer choice is answer choice A. Quantity A is greater. Okay, moving on to the next question. Here we are actually given some centered information where we have x is greater than y and y is greater than z. And the second statement reads that x times z is less than 0. Quantity A, we're comparing the value of x times y, and quantity B, we're comparing the value of y times z. So this centered information, we need to figure out what to do with the centered information, right? So I want to focus on the second piece of information we're given, that x times z is less than 0. Well, if x times z is less than 0, that means that one of the numbers must be positive while the other number is negative, right? Because a positive times a negative results in a negative number, which is less than 0. So for example, if I have 3 times negative 2, that's negative 6, which is less than 0. It can't be both positive, because 3 times positive 2 would be 6, which is greater than 0. And also x and z both cannot be negative, because a negative times a negative results in a positive. So x or z, one of the numbers has to be positive or negative. I don't know which one has to be positive or negative yet until I look at the first piece of information here, that x here is actually greater than z. Well, if x is greater than z, that means that x must be positive and z must be negative. So now that's a good thing, right? Now we actually have some real information. We know that x must be a positive number and z must be a negative number. And now, here's the thing though. What do we know about y? Well, y is in between x and z, and we don't actually know if y is a positive number or a negative number. We simply don't know, right? Because if I use hypothetical values and I say, hey, well, x is 100 and z over here is negative 100, well, y can be any number in between, right? It can be negative 5, or it can be even 99, because it's between 100 and negative 100. So we don't know. We simply don't know. Okay, fantastic. So now let's take a look at quantity A and quantity B. So here is one strategy that most students, and you are of course used to this strategy all your life because you've been practicing it. It's called the plug-in method, right? You're plugging in hypothetical values, and you will go ahead and plug in various scenarios and try to see which quantity is greater. I personally would not recommend using the plugging in method for this specific question. Why? Well, plugging in is a good method, but it's not the perfect method for this question, because you can save yourself some time by looking at this question logically, and this is how you do it. So I know that quantity A is x times y, and I know that x times y, so I know that x is a positive number. I don't know what y is. And for quantity B, I have y times z, and z over here is a negative number. This much I do know. So I have only two scenarios here, right? I have either that y is a positive number or y is a negative number. So let's see what happens. If, in this case, that I have a negative number for y, What does that mean? Well, x times y in this case is a positive times a negative, which results in a negative number, and a negative, which results in a positive number, and therefore quantity b would be greater. However, what happens if we make y positive? So let me go ahead and rewrite this now. So here is one scenario, and the other scenario, I'm going to write this here. I have x times y. I know that x must be positive. Y times z must be negative. But in this case, y is going to be positive. What happens in this case? Positive times positive is positive. Positive times negative is negative. Therefore, x times y is always going to be greater than y times z. And take a look at that. We have two different signs, right? If y is a negative number, quantity b is greater. If y is a positive number, quantity a is greater. So we have two different scenarios here, which automatically means that the answer choice is D, that the relationship cannot be determined from the information given. Why do I prefer this way? Because if you are using the plugging in method, you have to use different numbers, and sometimes you may not be using the right number, so you have to do it multiple times, right? Maybe you're sitting there with your scrap paper on the computerized version of the exam, plugging in 6 or 7 or 8 different hypothetical numbers just because you're paranoid, or just because you want to see and make sure, or just because, any kind of hypothetical numbers you're using, you keep getting that quantity A is greater. So plugging in is a good method. Particularly, I do prefer using plugging in method for multiple choice problem solving questions because it tends to help more. But you should resort to plugging in method for quantitative comparison questions when you really don't have any kind of idea, right? You're not able to make any kind of logical assumptions like this, and you're just lost. Go ahead and plug in if the question allows you to. If not, always try to be logical about it and try to do it this way. Okay, fantastic. Let's move on to the next slide where we're going to cover one last strategy for this video. Okay, fantastic. So in this slide, it's pretty obvious what the strategy here is. The strategy is avoid unnecessary computations. Earlier on the video, I told you that the ETS does not really want you to spend 20 minutes to solve a problem doing various arithmetic work. So in this case, you have to understand how to avoid unnecessary computations by simplifying the problem or making some logical jumps. So let's go ahead and look at this question first, okay? I have some centered information here. It reads, the Earth rotates around its axis every 23 hours, 56 minutes, and 4 seconds. Okay, so basically like 24 hours, right? This is just trying to give me a headache, right? Let's see if this is really important. Well, we're going to see in a second. Quantity A states the measure of the arc traversed by the hour hand on a clock from 10:15 to 1:07. And quantity B states the rotation of the Earth measured in degrees during the same time. Okay, so one of the first instincts of a typical student is, of course, going to be that, hey, well, I have a time problem here, and I will draw a clock here. And it's saying that my clock reads from 10:15, so 10 is roughly here, 15 is roughly here. So 10:15. And it's going to 1:07, and let's say 1 o'clock is roughly here. So what is that? That's going to be 1, and 07 would look something like this as well. And now I have to figure out the difference in time, right? I have to figure out how much time has passed, right? So I would do, well, most students would say, okay, well, from 10:15 to 1:07, how do I figure that out? If I spend 45 minutes, I can go to 11 o'clock, and then to get to 11 o'clock to 1 o'clock, that's going to be another 2 hours. And then finally, right, 2 hours gets me to 1 o'clock, and to get to 1:07, I need to add the 7 minutes, right? So I'm adding 45 plus 7 plus the 2 hours. So that works out to be, I believe, 2 hours and 52 minutes. So 2 hours and 52 minutes is a time that has passed, and I'm interested in the measure of the arc traversed by the hour hand. And I want to compare that to the rotation of the Earth measured in degrees during the same time. So obviously you can see that this requires a lot of calculations, right? There is actually a much easier way to do it, a very simple way. As soon as you can make if you can connect the dots, this question does not require any of this kind of computation over here. And in order to actually carry this, if you were to do it this way, you would probably spend, I don't know, probably another 2 minutes working on this problem. Here is instead what you should be thinking about, okay? You have to understand, okay, so here's my clock, and let's just pretend here's 12, and here's the 6, and here's the 9 and 3. Let's just pretend it's 12 o'clock, right? Let's just pretend it's 12 o'clock. And in order to go around the circle 360 degrees, that means that it takes me 12 hours to go through the entire circle, right? So 12 hours is equal to 360 degrees. Would you agree with me, right? Because if it's 12 p.m. now, the next time it will hit the 12 o'clock, well, 12 a.m., it will have gone around the circle one entire time, and that's 360 degrees. And to go around the clock 24 hours, well, that means that it's going to travel around the circle once again. So that's 360 plus 360, which is 720 degrees. That means in a 24-hour, in a 24-hour time period, I go around my circle 720 degrees. I care about this because quantity B states the rotation of the Earth measured in degrees during the same time. Now take a look at quantity B, right? Quantity B, well, you know that the Earth rotates around its axis basically once every 24 hours, but you should know that the Earth goes around itself, so it makes a complete circle only once in a 24-hour time period. That means that within 24 hours here, the Earth rotates only 360 degrees. So take a look at that, right? This is very important information. This comparison compared to this comparison. So in quantity A, we have the situation where 24-hour period, we travel 720 degrees. And basically that's twice of in quantity B, where the Earth rotates once every 24 hours and only goes 360 degrees. That means, what does that mean? That means that we don't care about this, right? Take a look at this. Okay, whatever, we traveled for 2 hours and 52 minutes. That means that my degree measured over here is going to be twice the value here than compared to how much the Earth would have rotated in degrees, because quantity A is going to be 2x. What does that mean? That means automatically that quantity A is always going to be greater, right? So notice how we don't even have to do any of this. We simply can understand that, hey, in a 24-hour period, we go 720 degrees. In quantity B here, in a 24-hour period, we have 360 degrees. So no matter how much time I've spent in quantity A, the value is always going to be 2 times the value as the degree measure in quantity B. So the answer is A. The point that I'm trying to make is you can try to avoid the unnecessary computations by making that logical jump. That concludes this video lesson over here. We have one more slide. This is a very important slide. Okay, this is the last slide, and I just want to emphasize that we do have videos that cover several questions in respect to the video lesson we've just covered. So obviously this lesson has to do with quantitative comparison, and therefore on the bottom of the screen you can click and you'll see that I go over one practice question per video, and usually you'll find anywhere from 2 to 3 videos of practice questions, and all of these questions range from the medium to difficulty range, just to give you that added extra practice. And I highly recommend that you go ahead and check those videos out.
check out our website at www.argoprep.com to access our full online GRE platform where you can access over 20 hours of video lectures, 500 plus practice questions, and 7 full-length practice tests.